Assalamu alaikum, dear students. How are you? I think all of you are well in grace of Almighty Allah. I am also fine. I am Mohammad Hiron Chaudhary, Associate Professor and Head of the Department, Statistics Department, Eden Mohila College, Dhaka. Welcome to all of you on behalf of Eden Mohila College online class. Today's topic is test of independence. Earlier I have discussed contingency table, general steps involved in contingency table, expression of 2 by 2 contingency table. Today I shall discuss test of independence, which is second year honors non-major course statNM 202, that is principles of statistics. Test of independence. Let us consider that a researcher has n units in a sample. The sample observations are classified according to qualitative characteristics A and B as follows. Let us consider that a researcher has n units in a sample. The sample observations are classified according to qualitative characteristics A and B, such as follows. A and B, it is B, not B, A, not A, total. Suppose this is A, B, C, D. Total A plus B, C plus D, A plus D, P plus D. That is N equal to A plus B plus C plus D. Here A, B, C, D are observed frequency. Observed frequency in different cells. Our problem is to test the hypothesis. Our problem is to test the hypothesis null hypothesis B to attribute A and B are independent. Alternative hypothesis, they are not independent. Our Problem is to test the hypothesis, null hypothesis. The two attributes A and B are independent. Alternative, they are not. To test the independence, our assumptions is the marginal totals and grand totals are fixed. The marginal totals, that is A plus B, C plus D, A plus B plus D, and grand totals are fixed. Under A0, the expected frequencies corresponding to A, B, C, D are expectation of A equal to A plus B, A plus C by N. Expectation of B equal to A plus B, B plus D by N. Expectation of C, A plus C, C plus D by N. Expectation of D equal to B plus D, C plus D by N. In the above 2 by 2 contingency table, if one expected frequency is found out, others are found out automatically. In the above 2 by 2 contingency table, if one expected frequency is found out, others are found out automatically. In the 2 by 2 contingency table, if one expected frequency is found out, the other frequencies are found out automatically. So the test statistic is pi square equal to n AD minus whole square divided by A plus B, C plus D, A plus C, B plus D whole use chi-square distribution with 1 degrees of freedom. Comment. If chi-square calculated is chi-square tabulated at 5% level of significance, A0 is rejected, otherwise accepted. Yates correction. Yates correction. The usual test in a contingency table is approximate test which can be modified by a correction is known as Yates correction. The usual test in a contingency table is an approximate test which can be modified by a correction is known as Yates correction. The need, when it is necessary, the need for correction arises from the fact that chi-square distribution is continuous, but the distribution of the frequencies is always discontinuous. We know chi-square distribution is a continuous distribution, but contingency table it is discontinuous. So we need some correction. This is called Yates correction. This is our 2 by 2 contingency table. This is our 2 by 2 contingency. This is discontinuous. But when we use chi-square test, this is continuous. This table is discontinuous. So to avoid this problem, Yates gave a correction. This is known as Yates correction. What is this correction? This correction is if AD is greater than BC, if AD is greater than BC, then we replace A by A minus half, and if AD less than BC, then we replace A by A plus half, and then adjoint other cell frequency to keep the marginal total fixed. This correction is replace A by, if AD is greater than BC, then replace A by A minus half. If AD is smaller than BC, then replace A by A plus half. Other marginal totals are fixed to keep fixed. So applying Yates correction for 2 by 2 table, our marginal total is this is A minus half if AD minus BC, applying this condition, AD minus half, our marginal total fixed. Since our marginal total fixed, so we can put B plus half, that is A plus B. A minus, that is C plus half, A plus C. It is B minus half C plus D, B plus D, that is N equal to A plus B plus C plus D. Marginal total fully fixed, so we can use these cells. We know our years for chi-square 2 by 2 contingent table, we know N into AD minus BC whole square, A plus B, C plus D, A plus C, B plus A plus B, A plus C, C plus D, B plus D. So applying this correction in this formula, we get applying this correction, pi square correction, and into A minus half B minus half BC, B plus half C plus half, B plus half C plus whole square. This is marginal total fixed, A plus B, A plus C, C plus D, D plus D. After simplification, we get that is AD minus AD minus A by 2 minus B by half plus 1 by 4 minus BC minus B minus C B by 2 minus C by 2 minus 1 by 4 whole square, 3A plus B plus C, C plus D, D plus D. Plus minus vanish, AD minus BC minus N by 2 whole square by plus B, A plus C, C plus D, D plus D. It is chi-square correction formula when AD is greater than BC. if AD less than BC, then its correction is n into BC minus AD minus n by 2 square plus D plus C plus D plus T. From the above two result, chi-square can be written as from the above two results, chi-square can be written as chi-square equal to n AD minus BC minus n by 2 whole square plus B plus C plus D plus T, which is known as Yates correction for continuation, which is known as Yates correction for continuation. Example, a group of couples of childbearing ages are classified according to wise education and family planning adoption. Family planning adoption as follows. Family planning adoption level of education, total illiterate, tertiary, primary, secondary, higher. Yes, no, total. Eight, 22, 25, 25, 17, 73, 25, 10, 125, 100, 95, 50, 30. Do you think that family planning adoption depends on level of education? Do you think that family planning adoption depends on level of education? At first, I have to set up null and alternative hypothesis, which is null hypothesis. Family planning adoption does not depend on level of education. Alternative hypothesis H0 is not true. Our expected frequency are E11 R1C1 by N 75 to 25 by 109.37. It is E12. Similarly, E24 equal to the test statistic is chi-square equal to yj square by eij minus m. That is 8 square 9.37 by square 35.63 plus up to dot square minus after minus 2. From table 2.05 3 equal to 7.815. Comment: since 12 chi square is greater than 12 chi square at 5% level of significance. So A0 is rejected. That is family planning adoption depends on level of education. That is family planning adoption depends on level of education. So viewers, no more today. In next another say I shall discuss another topic inshallah. Allah Hafiz, all the best.